Okay, kids, it's time for your Chapter 3 chemistry test review. The first thing we talked about in Chapter 3 was physical change versus chemical change. When you have a physical change, such as chopping up a piece of paper.
Not broccoli?
No, not well, it could be broccoli.
Broccoli.
Or water freezing. That would just be a state change, or in the case of paper, making it something smaller, but no new substance is produced. Unlike a chemical change where a new substance is produced, such as iron rusting or cooking something or burning something.
Can't get it back to its original existence. The next thing that we're going to talk about is to first get into equations, you have to understand parts of the equation. So you're always going to start off an equation with what's called the reactants. That's what you're starting with. That's then what's going to get changed. Then you have the yield sign, which shows you the direction of the reaction. And then after the yield sign or the arrow, it shows you what gets made or rearranged, and that's going to be your product. So it's going to go reactants, yield sign, and then the products. Those are your parts.
Chicken parts?
Chicken parts.
All right. The next thing we are going to talk about is evidence that a reaction has taken place. There are 4 types of evidence. One type of evidence would be a color change, and we saw that in the lab when our table salt turned yellow or orange. Another example of evidence would be temperature change. An example of that would be when you have the ice packs, when you injure yourself and you have to smash them to start that chemical reaction, and you feel that decrease in temperature. So we had color change, temperature change. Another piece of evidence would be formation of a gas. That would be when you see bubbles.
In the swimming pool. Or bathtub.
Or your bathtub. And the last one would be formation of a precipitate, and an example of that would be seashells. That's when you've got 2 liquids, so something coming from the sea animal plus the ocean, 2 liquids that form a solid. That is a precipitate, and those are your 4 types of evidence.
In the next section on 3.1, it discussed ways you can change the rate. The rate is how fast or how slow you can make that chemical reaction occur. The first one is going to be the concentration. The more concentration you have, the faster it will go. The less concentration, the slower. The next is temperature change. We talked about that with the gentleman from the Buffalo Bills, slowing down his body temperature with cold saline, slowed the rate of swelling, preventing paralysis. So the temperature, slowing it down or speeding it up can affect it. A third one is surface area. You increase the surface area, you're allowing more area to have a reaction around it, so therefore it can speed up the surface area. And the last one is a catalyst. A catalyst is something that you add to change the rate of the reaction, but it does not get consumed. Enzymes, which we have in our saliva and in our body to help speed the process of things up, but doesn't get used up or change the outcome of the reaction, is a 4th rate change.
The next piece of information we talked about were types of reactions. And remember, we gave you 8th grade examples and we gave you letter examples. The first one is going to be synthesis. That's when you have 2 individual elements. So I can use A plus B, and they come together to form a product or a compound or a molecule. So that's AB. If we're talking about 8th graders, Sally Sue, Billy Bob, they become a couple. That's synthesis. The opposite of synthesis would be decomposition. That's when I start out with a couple or a compound, so AB together, and it breaks apart or decomposes into 2 individual elements. So AB yields A plus B.
Can I do the next one?
Sure.
Okay, the next one that we had was single replacement. We have an individual element and a compound on the reactant side. Single element A, compound BC. A comes along and bumps out an element, and we now in the product side have a new element, in this case B, and a new compound AC. The last one is double replacement, where we will have 2 compounds on the reactant side, in this case AB plus CD. They switch up, and we now have 2 new compounds, AD plus CB.
Combustion.
Yes, I was just about to say
The
same.
last one that we don't have a visual for is combustion. But the way you can recognize combustion, usually on the reactant side, you have carbon and hydrogen. You always, always, always have oxygen. Then on the product side, you usually have carbon dioxide, CO2, and water, H2O. Combustion is when something explodes.
Lake, big lake. Okay, the next thing as we went into the chapter, section 3.2, is we talked about Lavoisier. What's his name?
Lavoisier.
I know. His law of conservation of mass. And Lavoisier stated that energy can be neither created nor destroyed. And with our chemical equations, which you start out with as far as atoms or elements on the reactant side, you must have the same amount of those elements or atoms on the product side, even if they get rearranged. So that is following the law of conservation of mass.
Then we moved on to 3.3. In 3.3, you learned about endothermic and exothermic reactions. In endothermic reactions, energy is typically absorbed. There is more energy on the reactant side. In exothermic, energy is released, so there is more energy on the product side. In endothermic, you tend to have a decrease in temperature. In exothermic, you tend to have an increase in temperature.
A great visual reminder for you is if you see the reactant plus energy yielding the product, that's an endothermic reaction. If you see reactant yielding product plus energy, you have an exothermic reaction. So if you can identify where the energy is, if it's on the reactant side, it's an endothermic. If it's on the product side, it's an exothermic. We also talked about, for endothermic and exothermic relationships, photosynthesis and respiration. We know that photosynthesis, you're going to have energy going in to the equation or the reaction, giving you an endothermic reaction. Exothermic respiration is exothermic because it produces that energy. It's on the product side. So 2 applications to real life is there for you.
All right.
The last thing that you need to know is the bond energy, and that ties in with where more energy is going to be to break things up. There's going to be more bond energy on the reactant side for endothermic, and then on exothermic, there's going to be more bond energy on the product side. You will need to know that from handout 15 from your notebook.
And I think that's it.
That's it. So good luck. Hope you're studying.
You've been studying.
Hope you watch this video
tonight
and use all your notes. And any questions, come see us during home base. Bye.
Bye.